Hey, this is Paul here. I'm at Okuma. We're looking at an MU8000V, the Laser X. I got Paul Kingsley. And Paul, what's your role for Okuma?
Senior Applications Engineer.
Cool. And this is some pretty awesome stuff. Let's take a look at this. And you were telling me about the fact that this is part of a turbine body. What we used to do is we used to make a really complex casting. Now there's a much simpler way to do it. Can you explain that again, what we were talking about?
So the idea here is typically a casing like this would be a forging. And the forging cost, because of the complexity of the part and the geometry that has to be added to it, is really high, and the lead times can be extremely long. Sometimes a couple of years in some cases. So the idea here is to make a simpler forging with less tooling cost, less lead time, then use the 8000V, which also has turning, so I can come in and actually turn the profile of the part to what you see here, and then from there I go to actually adding material using the laser. So we're doing directed energy deposition using the laser, and we're basically starting adding these features on as we go along. Once the features are all added, then we start machining. Once we get to a certain point, we go back and machine all of the floor around all of the parts, and we eventually have a completed part.
So for the kind of the uninitiated, this is sort of like BMW in Greenville makes an X3, an X5, a 5 Series. They make them off a platform. They don't have to retool the entire vehicle to come up with new options, put new options. You're telling me that it used to take as long as 2-3 years when I would change this casing, if I changed one of these receivers from a port to build this new casting. Now I can actually do this in a more standard format and add, almost like adding options on a car, I can add it to a really complicated piece of equipment.
Correct. Once we've done this, if the manufacturer decides to make a change to the part, then we just make a change to the program and what we're adding to it. But we wouldn't have to go back and have a part reforged again.
So is everybody doing this now? Is a lot of people actually using this in industry, or are you guys kind of cutting edge?
I don't think that anybody's actually doing this because of FAA approvals and stuff like that, but what we're trying to do is get the message across that this is where we think the technology could potentially be very beneficial, because of the huge cost savings and the time savings of not having to go through such a complicated forging process would allow you to go this route and be able to do a lot more things in a shorter amount of time, and hopefully for less cost.
So you're taking time out of the supply chain process, time out of the engineering process. You're creating more adaptability of a standard part.
Correct.
I mean, this is taking a pretty big, complex piece of equipment like a turbine, and maybe taking a significant amount of time out of the design and delivery of it.
Correct. That's the idea.
That's pretty cool. You guys are always on the leading edge of this stuff. I'm pretty excited for you guys at Okuma here.
We're trying.
Good stuff. Hey, Paul,
Yep.
Thanks for the time. And this is some really cool technology.